Welcome to the next learning unit in the chapter on PV system components. Here we look at how batteries can be integrated into a PV system. If you want to integrate a battery storage into a PV system, there are several possibilities. Let's look at a very simple PV system in which the battery is directly connected to the PV modules. In practice, however, you would never do this. We will see why in a moment. Let's imagine a sunny day. The energy from the PV module is sufficient to both power the loads and charge the battery storage. At some point, the battery storage is fully charged. However, the sun continues to shine and the PV modules continue to produce power. So there is still voltage at the battery storage and it continues to be charged even though it has already reached its maximum capacity. This is called overcharging. Overcharging can lead to various problems, such as overheating and reduction of battery life. A similar problem can occur when the PV modules produce less energy than is needed by the consumers. The battery is then discharged, which of course is what it is designed for. However, the energy from the PV modules may still be not enough even if the battery has already been discharged below the intended depth of discharge. Without further action, the battery would continue to discharge in this situation until the stage of charge is 0%. In the last learning unit, we saw that the life of a battery can be increased if the depth of discharge is limited. Deep discharge always has a negative effect on battery life. In addition, it may also happen that the PV modules supply no voltage or only a low voltage, for example, at night. In this case, a reverse current from the battery into the PV modules would occur in a dielectrically coupled system. Thus, the battery would power the PV modules, very similar to what happens in a series connection with a shaded module. As a result, the battery would discharge overnight and the modules would heat up in the process. To prevent all these problems just explained, a charge controller is now integrated into the system. The charge controller is responsible for regulating the current and voltage at the battery so that the manufacturer's specifications are met. This includes, in particular, protection against overcharging and deep discharging. In general, such a charge controller monitors the battery voltage for this purpose and disconnects the battery if the voltage rises above or falls below certain limit values. In practice, however, in the vast majority of cases, a PV system is also intended to supply AC consumers and has an inverter for this purpose. In such systems, the function of the charge controller is usually integrated into the inverter. In general, a distinction can be made between AC and DC coupled systems. In a DC coupled system, the storage unit is integrated on the DC side. A so-called hybrid inverter is used for this purpose. Such an inverter contains a DC-DC converter for the charge controller in addition to the DC-DC converter for MPP tracking. This way, the voltage of the PV generator and the battery storage are decoupled from each other. However, the pulse width modulation bridge of such an inverter is designed for the PV generator and is thus often oversized for battery operation. This results in higher losses in battery operation. In an AC coupled system, the battery storage is integrated on the AC side. However, this requires a separate battery inverter. The advantage of this system configuration is that the battery storage can also be easily integrated into an existing PV system at a later time. In addition, the battery inverter can be optimized for the size of the battery storage, resulting in lower losses. A disadvantage is the additional converter stage and the associated losses. Let's summarize. We learned The charge controllers protect batteries from overcharging and deep discharging. The function of the charge controller can also be integrated into an inverter. Furthermore, we have seen that in an AC system a battery storage can be connected on the DC or the AC side. When connected on the DC side, a hybrid inverter is used that converts both the DC power from the modules and the battery into AC power. When connected on the AC side, an additional battery inverter is required. Thank you for your attention.